Hi, my name is Chris Halstead, and I'm going to walk through the App Volumes Toolbox today, in particular how it interacts with Enzo. So the Toolbox will work with really any flavor of App Volumes, 2, 3, in this case, the App Volumes that's embedded into Enzo. So you can see here I'm connected into an Enzo environment. I've got some assignments. I can see, my applications in my application inventory. But one of the things we can't do today in Astro here is delete applications or delete app stacks. And that's one of the things that we're going to do and we can do with the Toolbox. We can, all of the same information that's accessible through Astro can be pulled into the Toolbox. So let's go ahead and log in. We're using the exact same API calls that Enzo and that App Volumes are using. So in this case, we're going to select here, connect to an Enzo instance. It's going to change a few things in the UI. It's going to add a new text box called tenant appliance IP. This is going to be the floating IP address of the appliance that sits on the customer's premise for Enzo. We're going to pull that information automatically from Enzo when we connect in through the APIs. So let's go ahead and connect in, and we're going to log in with our My VMware account first, so exactly the same way as we do through the web. Then we're going to be challenged to log into the domain. This is the domain that sits in the tenant's environment that the Enzo instance is bound to. We log in. Again, logging in with the exact same API calls. And you can see here it pulled the tenant IP, appliance IP, the floating IP. And it's going to connect to that to pull data from the legacy App Volumes API. So you can see here, we can pull information on systems that are connected in with an App Volumes agent, and these are Enzo systems. So this is something, again, that today we can't bubble this information up through Astro, so it's nice to be able to have this information. Things like logs, we can pull the App Volumes logs here very easily. We can do a tailed version of it, the full log, or we can even download that log. This is great for troubleshooting things like file syncs, and really just understanding what's going on as users are connecting in and out of the environment. We can view and also delete app stacks here. So we can see all of the app stacks that are available in the environment. We can right-click on them. We can get more information of what's actually installed into that app stack. So whether it's a standard app stack or a merged app stack, we're able to pull all those individual applications. We're able to see the file share where those app stacks have been pulled in from. And we can even synchronize that file share on demand if we want by just clicking the Sync File Share button, and it will initiate a new sync or import of that particular file share. Again, we can pick one here, VLC Media Player. We can look at one that's merged, 3 apps. We can see all the individual applications with versions. Last time it was synced, and just pretty detailed information. So again, one of the things that we can't do today, whether it's App Volumes 3 or whether it's Enzo, is being able to delete app stacks. So this allows you to do that. And not only that, but also you'll see here we have an option to delete files from the file share when you are deleting an app stack. So as long as the user has access, who's logged in, to the Toolbox, and the file server is accessible, it'll actually go through if that option is selected and delete any VMDK, VHD, or JSON files that are tied to that particular app stack or set of app stacks that are being deleted. If it can't contact the file server, it's just going to simply let you know that. So in this case, let's try to delete WinRAR. So it gives us a warning message. We select yes, and then say, oh, wait a minute, you can't delete this app stack because it has user assignments. This is really important. The way that App Volumes works is it uses a canonical numbering system for app stacks. And what happens is if you delete an app stack that has an assignment tied to it, that assignment is tied to a very specific ID. Even if you re-import that same application back in, it's going to have a different ID. It's not going to tie back to the assignment, and that assignment is essentially orphaned and essentially broken. So this prevents that from happening by checking if there are any assignments, if there are any attachments, and then in those cases, it won't let you delete the app stack. It's going to provide this warning message. So let's go ahead and delete one that I know has no assignments or attachments, VLC Media Player. So we go ahead, we say delete. It's going to again give us a warning. We say OK. it's going to come back and it's going to say it was successfully deleted. Now we can verify this by going back, refreshing Astro, and you'll see that the VLC media player is in fact gone. And this is an actual API call from XMP, so it's not only cleaning it up within Astro, it's also deleting the underlying VMDK file. And again, we could delete the files from the file share, but it's something that you typically with Enzo you wouldn't see a lot of. Writable volume. So writable volume management is something that a lot of our customers have asked for. How do we handle that within @volumes 3 and Enzo? And now, with this toolbox, it's pulling that data from the @volumes API. We can manage those writable volumes here. We can see them. We can take some actions on them. Expanding them, disabling them, enabling them, or deleting them. So in this case, I'm going to disable this particular writable volume. It's going to come back, and you see it made the change. I could select really, as many as I wanted to here, delete it. So as long as it's not user attached, you're able to delete a writable volume. If it is user attached, again, just like with the application, it will not let you delete it. And you can see here now we have no more writable volumes. Attachments is also information that's pulled from the legacy @volumes API. We'd see here if any writables, if any abstracts are attached, which computer they're attached to. A lot of really great information to be able to troubleshoot what's going on. We'll show that more when we go into the @volumes 3 video. I can see current assignments, and you can see here, since this is an Enzo instance, we're actually showing desktop pull information as well. So not only native applications, customizations, but it'll also pull data in on desktop pools so that you can see that desktop information that's specific to Enzo. And we can certainly add anything that's available or accessible through the API into this environment. If we right-click on one of the assignments, we'll get some more detailed information. We can see all the different applications that are comprised within that particular assignment, and we can see the users which are assigned that particular assignment, along with the type of service. In this case, it's a native application and the operating system. We can also look at a list of applications. So we can see the list of applications that are contained within all the app stacks that have been imported into the environment. This is really nice because it gives you a very quick way to see not only the application, the version, if there are any assignments tied to it, but also the parent app stack very, very quickly. And this is a nice way when you're going to maybe delete an app stack or figure out how you want to assign an app stack to a user, you're able to see exactly what's going to apply to them and which version, which operating system, and if there are any existing assignments already. You can see here also where it's showing us that we're actually connected to a particular tenant appliance to pull all that legacy @volumes information. Now, if we weren't able to connect to that appliance for whatever reason, we're not going to be able to pull this the legacy @volumes information, but we're still going to be able to connect to the XMP API, which is located in the cloud, and pull the information that would be @volumes 3 related. So we'll go ahead and we'll disconnect from this instance. We'll connect into another instance, and the instance that I'm connecting into now, I know that has a private addressing for the tenant IPs. The tenant appliances. So I'm not going to be able to access them from where I am right now. So again, we log in with my VMware account. It's going to make the API calls. We're then going to be challenged to log into the particular domain. Log in. And once you log in, it's going to pull the information out from using the Desktone API of the pulled tenant appliance IP address, and type password in wrong. It's going to try to connect to it, and it's going to try for 5 seconds. And if it can't connect to it after 5 seconds, it's going to fail and basically say, I can't connect to the tenant appliance, but I'll still give you all the data from XMP. I'm not going to be able to provide all the legacy @volumes information, but we'll still be able to connect to XMP and view, delete abstracts, view attachments. View assignments and view applications. So if we go over to some of those legacy tabs, we'll see that we actually can't connect to them now. And it's going to let us know that we can't connect to the tenant appliance. But if we select one of the XMP-based solutions, such as assignments, applications, or in this case, app stacks, we're going to be able to see the information. In this particular tenant, there are no app stacks yet. There's only one assignment, which happens to be a desktop assignment, but we can see that information just fine, even though we're not able to get to the tenant appliance IP address. So hopefully this was helpful. This is, again, the App Volumes Toolbox working with Enzo. Thanks.